Welcome to the lecture on dealing with missing values. In the previous lecture, we have analyzed the data with complete cases. The complete cases in the sense we have not considered the missing values in the analysis. Wherever there were missing values, we have omitted those missing values and then we proceed with the analysis. That would not be the real case scenario, because in a real time scenario you would be having lots of missing values which you will be dealing with. In that case, there needs to be a way or an approach on how to deal with those missing values. So, in this lecture we are going to see how to identify the missing values and some of the approaches to fill in those missing values. So, these are the major concepts that we are going to see in this lecture. So, prior to importing your data into Spyder, we need to import some of the necessary libraries that are required for the analysis. So, we are going to import the OS library, that is to change the working directory, so that you will be able to access the file. Then we are going to import the pandas library as PD, and this is to work with data frames, so that we can use any functionalities that are from the pandas library. Next, we can now change the working directory by using the chdir command. Inside the function, you just need to give the file path of it. So, I have given the file path. Once you set your working directory, you will be able to access the file in your current working directory. Next, let us import the data into Spyder. I am importing the toyota.csv which we were working on, and I have set the first column as my index column, and I have also given some set of string values that needs to be considered as Python NaN values, and I have saved my output to an object called cars underscore data. Now, cars underscore data becomes the data frame. Whatever I am going to do, that should not be reflected in the original data that I have now, rather I can just create multiple copies of data, so that I can work with the duplicated data. So, let us create copies of original data. So, using the dot copy command. So, I am creating the copy from the original data cars underscore data, and I am saving that as a new data frame called cars underscore data 2. So, this is one copy, and I have made also another copy called cars underscore 3 from the cars data 2 data frame. So, I have now two copies of data from the original one, that is cars underscore data 2 and cars underscore data 3. Now, we are going to see how to identify the missing values. In pandas data frames, missing data is represented by NaN, and NaN is just an acronym for not a number. So, whenever you have a blank cell in your CSV file, the Python will automatically read it as NaN value. So, all those NaN values will be treated as missing values in pandas data frames. And if you want to check the null values in pandas data frames, there are several functions that are available to do any operations that are related with dealing with missing values. We are going to consider only the two functions that are used to check the null values in pandas data frames. Two of it has been shown here. The first one is null and the second one is na. Both of the functions will account for the Python default NaN values. These functions can be used to check the null values in your pandas data frames, because before proceeding with how to deal with your missing values, you need to identify whether there are any missing values or not, or how many of them are there. In that case, these functions will be really helpful to do that. These functions basically returns a data frame of Boolean values which are true for NaN values, and these functions returns a data frame of Boolean values which are true for NaN values. Basically, you will get an output with only true or false values. So, wherever you have NaN values, you will see it as true, and wherever you do not have NaN values, rather you have other values, then you will have the value as false. We will see now how to use these two functions. So, as I mentioned, these SNA and isNull are the functions that are used to check the missing values in the pandas data frames. So, we are going to get the count of missing values present in each column. Let us see how to do that, because I do not want to look at how many missing values are there in a complete data frame, rather I just want to look at how many number of rows are missing under each column. So, that it will give me an idea on how to proceed with the missing value, so that it will give me an idea how to deal with that missing values. So, the syntax is data frame dot isna dot sum in order to get the count of missing values present in each column, and you can also use isNull function with the same syntax. So, I have shown the code here, that is cars data 2 is na dot sum. We will see what the dot sum is used for. Similarly, I have used it for isNull. Though both of the functions give you the same output and gives you the same information, you can choose any one of it. So, now let us look at the output. So, the output shown here is for the function is NA, and you are getting the column names. Correspondingly, you are also getting how many number of rows are missing under that particular column. For example, age has 100 rows where there are missing values, kilometer has 15 rows where there are missing values. Similarly, fuel type has 100 rows with missing values, horsepower has only 6 rows with missing values, and the met color has 150 rows with missing values. None of the other variables have missing values. So, now we have got an idea about how many number of rows are missing under each of the columns. Now, we have got an idea about how many number of rows are missing under each columns. Now, it is not enough to know that, because we need to check whether 100 rows missing under age is completely different from the 100 rows that are missing under fuel type, or there are any sequence or there are any combination of missing values that are available in our data frame. In a same row, you want to see whether only one column is missing or multiple column values are missing, because whenever you have missing values, you need to have two types of approach. One is to completely get rid of all the rows wherever there are missing values, and the other one is to have an approach to logically fill up those missing values. So, these two cases depends upon the problem that you have. So, if you have a row when all the column values are missing or most of the column values are missing, then there is no point in refilling the missing values with any substitute value, right. You can just get rid of that particular row alone. In that case, removing the rows will help you, and even if there are, and the second thing is, if there is no pattern to your missing values, like if it is just randomly missing all over the cells, then you should go and look at an approach to fill in those missing values. In that case, this numbers will not give us an idea about that. We need to subset all the rows and see where the missing values are there, and then we can decide on what we have to do with the missing values. So, now we are going to subset the rows that have one or more missing values, because I need to consider a row wherever there are only one column is missing and as well as more than one column is missing. In that case, the code shown here will do that. From the cars data 2, I am subsetting the rows wherever there are missing values using the function is null, and I have given dot any of axis is equal to 1. The 1 represents column. We are telling the function give me all the rows wherever at least one column value is missing, and we have saved that to an object called missing. So, it becomes a data frame. Let us see how the missing values are, or now let us see where the missing values are there. So, once you read that, you will get that in your variable explorer. Let us check the dimension of it. It is a data frame now, and the dimension of it is 340 rows with 10 columns. So, there are 340 rows where at least one column value is missing. So, now let us see where the missing values are there. Right click your missing data frame, you will get this window. So, the snippet shown here is the missing data frame, and I have filtered out all the rows wherever there are missing values under the age variable, and if we look at the corresponding columns, there are no missing values except only one. There is no pattern to the missing values, it is just missing completely in a random case, because it is completely randomly missing under each variables. If you were to subset all the rows wherever there are missing values under kilometer, then that is also the case. You do not have any pattern to it. That holds good for the other columns. I have just shown you for an example to illustrate that there are no pattern to the missing values that are there here. Rather, the missing values are completely random in the variable age. So, now in that case, we can't just go ahead and drop all the missing values that are there in your data frame, because if you consider removing a row wherever there are at least one missing value, then you will get rid of 340 observation from 1436 observations, right. That is a huge loss of information that you are going to have. Now, we should have an approach to fill in those missing values. What can be the approaches to fill the missing values? There are several ways to fill in the missing values. In this lecture, we are going to look at two ways of approach. The first way is filling the missing values by mean or median in case of a numerical variable. That is one of the standard way, or that is one of the simplest way based on which you can fill in all the values. So, for any numerical variable you can look at the average of it or median of it, then you can have that value to fill in all the missing values. Similarly, you can look at a modal value for the categorical variable to fill in all the missing values in your data frame. The modal value is nothing but whichever category of the variable has the highest frequency. If that category occurs most frequently, then you can replace all the missing values with that category itself. So, these are the two ways of approach that we are going to see to fill the missing values here. As I mentioned, there are several ways through which you will be able to fill in the missing values as well. So, now we are going to impute the missing values. Prior to that, we have to look at the description to know whether numerical variable should be imputed with the mean value or the median value, right. Because if you are going ahead and filling the missing values with the mean value, that could also be a problem, because if you have any extreme values in your data, that might cause you the mean value very high or very low. If you have very low value in your data, that can tweak your mean value to the lowest value, but if you have an extreme value in the other end, like higher end, then that can also mislead your mean value. In that case, you should always go for median, because while calculating the median, you basically sort all the values in ascending order and you will be taking exactly the middle value if you have odd number of observation. But if you have even number of observation, you will take the middle two and then you take an average of it, and then you will use that value as the median. We have to know about the distribution of the variables to basically decide on whether we are going to impute it with median or mean. So, data frame dot describe is the function that is used to get the descriptive statistics that summarizes the central describe function basically. So, there is a function called describe. You can use that for a data frame. So, the syntax is data frame dot describe. The describe function basically generate descriptive statistics that summarize the central tendency, dispersion and shape of data sets distribution, and that excludes all the NaN values and give you those statistics. So, now we are going to check that using the describe function. So, this is how we use the function. We use the describe function followed by the data frame name. So, let us look at the output of it, the input being shown here and the output being shown here. So, if you look at the price variable, it basically gives you count, mean, standard deviation. From minimum to maximum, it is called as the 5 number summary, because it gives you minimum, maximum and the 3 quantiles of it. So, the count gives you how many number of observations are there under price, and the mean is nothing but the average of the price. The average of the price of the car is 10,730 euros and the standard deviation is around 3,626. The minimum price of the car is 4,350 and 25% represents that 25% of the price of the car is less than 8,450 and 50% of the car's price is less than 9,900 euros. And if you look at 75%, then you can say that 75% of the car's price is less than 11,950 and the maximum price of the car from the data frame that we have here is 32,500. So, when you look at the numerical variables, the missing values are there under age, kilometer and horsepower. So, if you look at the mean of the age, on an average the age of the car is around 55 months, and if you look at the median, you can see that median is also represented by 50%. So, you can say that, and the value being here is 60. The mean and the median are closer, there is no much deviation from the mean. So, according to the age variable, we can go ahead and impute it with the average age itself instead of going ahead with the median value. Next, when we look at the kilometer, the average kilometer that the car has travelled is 68,647 kilometers and the median kilometer that the car has travelled is 63,634 kilometers. But if you see, there is a huge difference in the kilometers travelled. There is about 5,000 and odd difference. So, in this case the mean is far away from the median. So, in this case you can't go ahead and impute it with the mean, because that gives you a higher number, that can be a reason because of any extreme values under the kilometer variable. Rather, we can go ahead with the imputation of median for the kilometer, because it basically gives us the exactly the middle value of it. So, we can use median for kilometer, and then we can look at horsepower. The average horsepower of the car is 1000. the average the average horsepower of the car is 101 and the median horsepower of the car is 110. There is no much difference between 110 and 101. We can fill in the missing values using the mean value. So, now let us try to impute the missing values of the age variable. So, for that, as we know that since there is no much difference between the mean and the median, we are going to impute the age variable with the mean value of it. So, let us just try to see what the mean value is for age variable. So, let us calculate the mean value of the age variable by using the mean function, and you can use the mean function along with the specified variable from the data frame. I am accessing the age variable from cars underscore data 2. Average age of the car is turned out to be 56 months old. Now, we are going to use this value to replace all the missing values under the variable age. So, to fill any NA or NaN values using a specified value, there is a function called fill NA. Again, there are so many functions that can be used to replace the missing values with a given value, but here I am illustrating you the example with fill NA function. You can use that on a data frame. So, the syntax being data frame dot fill NA, we will see how to use this function. Basically, the function is used to fill in all the blank or NaN values with the given value. So, basically inside the fill NA function, you can specify the value with which you are going to replace all the missing values with. So, here I have given the function that needs to be used to calculate a value, and that value can be used to fill in all the missing values. I have not given the exact value here, rather I have just generalized the function saying, so calculate the age mean, calculate the mean of the age variable, and then use that value to fill in all the missing values of the age variable. And what is the value I have shown here, that is 55.67. Basically, I wanted to fill in all the missing values on the data frame cars underscore data 2. So, I have given in place is equal to true. I have break the line here for the presentation purpose. You can continue in the same line also. So, now we have replaced the missing values under the age variable. So, now we are going to impute the missing values of the variable kilometer. So, here as we saw from the kilometer variable, the mean value is really deviating from the median value. That might be the reason, because there can be any extreme values under the kilometer variable. So, to get rid of that confusion, we are going to use the median function, so that it will give us the exact middle value of it. So, we are going to calculate the median value of kilometer to see what the median value is. The median value you can calculate it using the function median followed by the variable from a data frame, and then you got a value called 63,634. That means that the median kilometer that the car has travelled is 63,634 kilometers. So, now we will use this value to replace all the missing values. So, we are going to use the same function, that is fill NA. So, I am going to apply the fill NA function onto a data frame called cars 2 under the variable kilometer, and inside the function I have just given cars data 2 kilometer dot median. So, that the median value will be calculated from the kilometer, and then that value will be used to replace all the missing values, and I have given in place is equal to true. So, that all the missing values will be replaced in the existing data frame itself. So, now we are going to impute the values. Now, we are going to impute the missing values of the horsepower variable. So, if you look at the horsepower variable, we have seen that the mean and median are not very far away. The mean was closer to the median. So, in that case we can go ahead and impute the missing values of the horsepower with the mean value. So, here I am calculating the mean of horsepower by accessing the horsepower variable from the data frame cars underscore data 2, and if you look at the output, the average horsepower of the car is 101.47 and odd. So, now we are going to use this value to replace all the missing values of horsepower. So, using the same function fill NA, I am replacing all the missing values using the mean of horsepower, and we are filling the missing values in the existing data frame by giving in place is equal to true. Now, we have replaced the missing values under all the numerical variables like age, kilometer and horsepower. So, now let us check for the missing data after filling those values. So, now we have replaced the missing values under age, kilometer and horsepower. Let us see whether there are any missing values under that or not. Yes, there are no missing values, but if you can see there are still missing values under fuel type and met color because we have not still touched on that variables. So, now we are going to impute the missing values of the categorical variables. So, as I mentioned earlier, for any categorical variable, the simplest way to fill in the missing values of categorical variable is to check for the most frequently occurring category and then replacing that with the missing values. So, for that we need to understand what are the categories are there under the fuel type, right, and we need to understand the corresponding frequencies as well. So, for that there is a function called value underscore counts that can be applied onto a series, and the value underscore counts basically returns a series containing counts of unique values. The output of the function will give you the values in the descending order. So, that the first element is the most frequently occurring element, and it gives you the frequencies of each category by excluding all the NA values by default. So, we do not need to remove the missing values and then get the frequencies of it. By default it excludes all the missing values. So, this is how we use the function. Cars data 2 is the data frame name. Under that I am accessing the variable called fuel type. By giving dot value underscore counts, you will get an output which is shown here. For example, the petrol has the highest frequency, that is 1177 observations are of petrol fuel type, and only 144 cars have diesel fuel type and only 15 cars have CNG fuel type. In this case, it is very clear that the modal value would be petrol. If you want to get the modal value separately, then you can also do that. You can also use the same function. You can give the index as 0. Since in Python the indexing starts from 0, the 0 will give you the first value of the output of value underscore count. What would be the first value of the value underscore counts output? It would be petrol, because since it has the highest number of observation, it was shown at the top. So, when you access it using the index 0, you will get a value called petrol. Now, you will be able to use this value to fill all the missing values of fuel type variable. Let us see how to do that. You can use the same function, that is dot fill NA. I am using the same function from the cars data to data frame. I am accessing the variable fuel type and I am applying the fill NA function on it, saying that, and inside the function we need to give a value so that the missing value will get replaced. Here I am not giving petrol directly, rather I am giving the whole function here, so that the code will be generalized. It is, you do not need to tweak it whenever you want it, because just to write a generalized code. So, here I am filling all the missing values with the most frequently occurring category of fuel type. So, petrol will be used to fill in all the missing values of the variable fuel type, and you know here we have used in place is equal to true. So, that we are replacing the existing data frame itself. Now, by using fill NA, we have replaced the fuel type missing values with the petrol fuel type. We are going to now consider the met color variable. Here also we are going to impute all the missing values of met color with a modal value of the variable met color. Met color basically the metallic color of the car. Basically, it will have two values. As we know, the met color has two values. 0 represents the car does not have a metallic color and 1 represents the car has a metallic color. So, there are several ways using which you will be able to fill in the modal value. In the previous example, we have seen how to fill in the missing values using value underscore counts and accessing it from the index. Now, we are going to use the mode function to calculate the modal value of the categorical variable. So, to get the mode value of the met color, we can use it as data frame and access the respective variable and then use the function dot mode. The dot mode function gives you an output which is shown here. It basically gives a value along with the index. The mode value of the met color is 1.0, since it has missing values, it is giving you in floating point, that is 1.0, ideally it should be 1, and the index of the value is 0. So, why you are also getting an index? While calculating the median or mean, you will not be able to get the index, because median or mean can only be a scalar value, but mode cannot be a scalar value, or mode need not be a scalar value. Mode can either be bimodal. There are many cases where a variable can have bimodal or more than 2 modals. So, in that case you will have continuous index. In this case, since our variable met color has only one value as mode, you are getting only 0. So, now to fill in all the missing values using the specified value, we use the function dot fill NA. So, now I have used the fill NA function onto a variable metallic color, that is from the data frame cars underscore data 2, and inside the function I have specified that calculate the mode from metallic color variable and replace all the missing values. So, here I have also given the index to it, that is just because the output always comes with the index. If you have bimodal, then you will always have another index as 1 and you will have the another value. That will be the case where you have both the categories have the same frequency. In that case, you can choose any one of the value which is required for the analysis, but here which is more important for the analysis. But here, since I am very clear that I have only one value and that the modal values index is 0, I have given it as 0, and I am making all the modifications onto the same data frame called data 2. So, I have given in place is equal to true. So, now we have replaced both fuel type and met color variable. Now, we have replaced combinedly both numerical as well as categorical variables using different approaches. So, let us check for the missing data after filling in all the values using the isNull.sum function that has to be applied onto the data frame. In a data frame cars underscore 2, check whether there are any missing values. If there are any missing values, get the sum of it under each column. That is what the function describes. And if you see here, none of the columns have missing values now, since we have already imputed all the missing values with the logical approach. But we have imputed for all of the variables separately using the same logic, right. For example, for a numerical variable we have imputed with the mean or median, and for all categorical variables we have imputed with a modal value. So, this can be the case where you have only missing values in 6 to 7 columns. What will you do whenever you have missing values in multiple columns like 50 to 60? In that case, there can be a simple function which will do the imputation in one shot. We are going to use that. So, to fill the missing values, that is NaN values in both numerical and categorical variables at one shot, we are going to use a lambda function. Apply functions can be used whenever you want to perform any operations column wise or row wise. It can be used any other cases, but here this apply function will be used across columns. And if you see here, I am not using the cars underscore data 2, because the cars underscore data 2 does not have any missing values now, since we have already replaced everything. If you can recall, I have created another copy from the cars underscore data while reading itself. In that case, the cars underscore data 3 still have missing values, because we have not touched this data at all. So, I am using that data set and I am using an apply function, so that whatever function that I am giving inside the apply function, that will be applied across all the columns, and the function that I am using inside the apply function is a lambda function. Lambda function is an anonymous function and a powerful function whenever you use it inside a function, and here I am using it inside an apply function, and I am defining a function called x, and I am using a predefined function called fill NA to apply it across all the columns. So, what it basically does means, fill NA, we know that wherever there are missing values, it will replace it with the given value that we are giving it inside the function. So, what value that we are giving here? We are not giving a value, rather we are giving conditions to it. We are giving if else conditions, like basically our target is to fill in all the missing values of numerical variable with mean, and to fill in all the missing values of categorical variable with mode. In that case, give a condition saying that calculate the mean of each and every variable if the variable's data type is of float, else calculate the mode value of each and every variable and then use that value to replace with. So, that is what the function does. So, using this function we have just replaced all the missing values at one shot. Wherever there are missing values in numerical variable, everything has been replaced with the mean value of each and every variable, and similarly wherever there are missing values under any categorical variable, for each and every categorical variable separately the modal value will be calculated and then that will be used for filling those missing values. So, once we do that, let us check for missing data after filling all the values. So, I am checking whether there are any missing values under the data frame cars underscore data 3. The output is also shown here. If you see, all the values are 0 here because we have already imputed all the missing values, that is why you are seeing all zeros here. So, now we do not have any missing values under any variable, but as I have mentioned, this is not the only way that you can go ahead with the imputing with missing values. There are several approaches that are available to impute all the missing values. The way that we have shown here is the simplest of all, by just imputing it with mean or the modal value. Let us summarize whatever we have seen till here. We have seen how to identify the missing values. You have also seen how you can identify the pattern of your missing values by subsetting all the rows and seeing whether one row has only one column value missing or multiple columns are missing, and then by arriving at a decision that the missing values are there randomly under each column, then we found out an approach to fill in all the missing values. We have seen two approaches, that is mean or median imputation and mode imputation. Mean or median imputation is only for a numerical variable and you use mode imputation for a categorical variable. Thank you.